Hi everyone, welcome to Synopsis. So this session is hosted by Pascal Amah, and the title of this workshop is called AI Native Engineering, Accelerating the Software Development Lifecycle. Pascal is the Chief Technology Officer at Wowzy, an influencer marketing SaaS platform where he leads the technology strategy, systems, and innovation. He has over 15 years of experience and in data. He has over 15 years of experience in data and software engineering strategy and management, spanning various domains and industries. At Wowzy, he has transformed the company into a technological powerhouse, spearheading the development of Africa's largest influencer-led campaign management, as in, as well as influencer payment and value-added services system. He orchestrated and guided the expansion of the technology team and transformed the engineering backend. He's proficient in Django, AWS, data pipelines, and governance, and has a keen interest in serverless microservices and event-driven architecture. He holds an executive MBA from Quantic School of Business and Technology and is the co-founder of several startups. Pascal is passionate about building and scaling data, software, and technology teams that deliver bespoke and innovative solutions. Everybody give it up for Pascal. Pascal, you're the next.
All right, thanks, David. Hope you guys can still hear me. I'm already presenting. Okay, great. And thanks for the intro, and also thanks for having me. I would have loved to be there live, but I mean, so happens that I'm presenting virtually. So good evening from Enugu. David has done an introduction. David is name and seen on the screen, right? So I hope that's the right. All right, cool. So today we're going to be looking at AI native engineering, and the aspect of it we're going to be looking at is accelerating the software development cycle. I want this to be mostly a discussion. Take my initial presentation as just, thought provocation, if that's any proper type of communicating, and then hopefully we'll have some discussion around it. Myself, in my own words, is I first of all see myself as a learner. Like at any given point in time, I believe I'm learning. That in the core mentorship, I don't call it that. I call it co-learning because everyone brings something to the table. I'm CTO at Wowzy, and I also advise a couple startups around engineering, product, and AI strategy. I've implemented actual ML and AI native solutions on platforms that are actually working, not just the talking of it or the theory of it. And today I'm focused on AI-driven product strategy, engineering transformation, and operational excellence. Like, I love the whole tech ecosystem from start to finish. Most people know me as a data person, but I believe I've evolved way further than that at this moment. So the first thing is, why this topic and why does it matter now? I would say the AI revolution in software engineering, it's becoming something no single person who wants to be serious with anything technology can ignore, right? AI is rewriting software engineering every day, even as I speak. I understand it's been a long day, so I'm going to try to make this as fast as possible so that everyone can get at least one item from here. So AI has moved from novelty to a real co-worker across the software development cycle. It's no longer like something 2-3 years ago. We're experimenting with a lot of things. Today, we're actually trying to apply one or two things in actual platforms. Teams are redesigning how they build, test, ship, and operate software. But most are still in the adoption phase. I mean, and that's really okay. And I think that's a great place to start. People are still experimenting on this. They're still trying to figure out what works, what doesn't work, how can we make it work for us. So, and that brings in the gap, right? The gap is that many organizations are experimenting with AI tools, but few have repeatable patterns. I mean, the things that help you are the things that you have mastered, are able to put them into structured systems and like basically repeat them because they are not working. If you can't repeat some stuff, it's probably not working for you yet. So that's the gap, at least myself, I see today. What we are going to cover here will be a number of things. What actually works in real engineering environments, common failures and common failure modes, and where AI tools overpromise, or maybe where we over expect them to deliver. How to build responsibly and sustainably with AI. We're going to look at almost everything I'll be saying today. It's going to be from a case study, an actual case study of an organization that has done this, learned, and continued to try to scale it. And then finally, we're going to see some actionable patterns one can apply immediately, like working out of here, something they could actually start working with. What we'll cover today, I've already said something about that. I mean, defining what's AI native engineering. I'm going to base everything from a real life case study, see cross-functional learnings at different parts of the software development life cycle, see what an SDLC is per se, right? Like what's the software development life cycle, patterns and practices, even if we don't go deep into it. We're going to see some interactive application and a rough implementation roadmap. I want to be clear about what this is not and probably what it doesn't cover and what it presumes that it's already on ground. First of all, this is not a session on requirement gathering or product discovery. Any technology team, especially in a technology company, knows that requirement is king, right? This is presuming that at the start of the software development life cycle, a clear product is already known, even if it has not been tested, but at least there's a structure. There is that story, right? A product manager will tell you about a story. This is presuming a story is already there. We know where we want to get to, and we want to start building to get to that point. Secondly, I mean, I think I just made this point. I mean, the core problem has been identified, requirements are clear, and the constraints have been already understood. Our focus begins after this clarity is established. We are not going to look at how AI could help us create or establish this clarity. We are presuming that the software development cycle we are talking about today, software engineering, for me, I tell everybody that the software development side of any product, for me, is the cheaper part. Let me not say the cheapest part, because the biggest disagreement between engineering and product today is that product will say, okay, then give me what I gave you. Engineering will say, I mean, your requirements are not clear. I believe that clarity of requirements and what needs to be done, especially what can be called the most viable product from a certain product or feature, is the most critical part of everything. This session is not trying to do that, trying to see how AI can help us establish that. It's actually presuming that this is already done and want to go straight into the software development lifecycle. So we'll begin with understanding what the software development lifecycle is. I will try not to make it technical, but the software development cycle is that journey from when a story has been told, right? I'm calling it a story per PM terms, but the story is, what do we want to produce? We want to create a mobile app. We want to create an extra platform or an extra feature on a platform. We have figured out what that extra feature is. Maybe we don't know whether it's going to work, but at least we have an idea of how that thing needs to be. So the journey from that requirement that hopefully is clear, all the way to producing the outcome, which could be a mobile app, a web app, a progressive app, whatever you call it. That's what I'm referring to as the software development lifecycle. Now, it's a structured process that guides how software is built. I think that's the shortest form of it, from initial concept to final production and ongoing support. The SDLC actually includes continuous support. Some people think that when they build, they're finished. No, when you build, you continue to follow it up and to support exactly what you have built. So the first part is the planning. The biggest thing I'm going to take away or try to make very clear around planning is that grooming is critical. Grooming is everything. If you don't groom, please don't start. For every team I've managed, I tell them that grooming could happen over 3 different sessions across the 3 different days. First of all, everyone who is part of the building has to come together with the PM to understand exactly what needs to be built. That's grooming, right? For the first day, everyone sits together, understand what needs to be built. We go away and come back for a second possible day where you go and do certain proof of concept on your side, design, engineering, architecting, whatever it is, and come back for a possible follow-up questions to the product manager or whoever is leading that project. If there is none of this, we presume that on the second day that everything is clear for everybody and everybody goes away to start doing their stuff. Assuming that's not clear and there's some questions that are brought in by the engineers or designers, that's clarified, and we come on a possible third day where everyone hopefully goes out with clarity. Everything, as far as I've seen, with different teams, different organizations, builds on the clarity of the requirements. If you don't have a set of requirements, it's not clear to the people who are going to build this, a lot of things are going to go wrong. Now, once these requirements are clear, take it to the design, right? Almost everything we are going to build today that people are going to directly use will have a front-end interface, right? So user experience and everything starts from the design side of things. We look at the development, which is the actual engineering, if you call it that. Sometimes I call it the core engineering, where the code gets written and things start taking shape. After that, of course, there should be testing, and followed by testing, you deploy whatever you have. And then after deployment, like I've said, maintenance and support is a critical part. What we are going to be talking about today will actually center on only 3 parts or 3 sections of what we are seeing here. So the planning, the design, and the development. When you say AI native engineering, what do we refer to? AI native engineering represents a fundamental shift in how we approach software development, right? Look at the things I have in bold and underlined. It's just a difference between seeing AI as a co-worker within the system or just an optional productivity tool. AI native engineering would tend to be when AI becomes a co-worker, it's part of the flow, it's part of the platform, not just something you could use or not. So that for me is what I would refer to AI native engineering. Sorry, I went back. So the areas we could use this in the software development cycle include in prototyping and ideation. This is, from my experience, one of the best and most profitable places we can use AI in the software development life cycle. Implementation and testing is also another interesting part that we are also able to use it. AI augmented documentation. This is, like, personally, as an engineer also, one of the best uses of AI I've seen in the software development life cycle. And human-in-the-loop guardrails, we tend to think that the more AI does things for us, the better we are building, but that really depends. I see that where there is a human in the loop and there are actual guardrails, then we tend to have better results. And finally, continuous feedback loop. For everything you do, it has to be assessed. Is it working? It mustn't work, right? But you have to know very fast. From my experience, you want to know very fast whether it works or not. But whether it works or it doesn't work is actually not a big deal. Just be sure that you're trying to solve a particular problem at a time. Now, why AI native engineering matters? There are very clear advantages that come with trying to build with AI, from where you have the clarity around requirements to when you start designing, building, the actual engineering, and the rest of it. Now, the first one is that it dramatically accelerates your prototyping. Anyone who works with an engineering team, or at least a product-led organization that's trying to roll out features, knows that it's critical to figure out whether something we think is working or not, and how we can assess whether it's doing that which we want or not. Before today, you find out that you have to do mock-ups, several versions of designs, but today with AI, that has gotten dramatically faster and easier to do. And I mean, you know, as you are doing it faster, it means that you tend to come out with higher quality. One of the things that especially strangles a startup when we're trying to build a new product is the fact that we need to check a number of things over time. Startups usually don't have that time. You are told to deliver this in 30 days, in 45 days. I mean, how are you going to know whether the button here or there, whether the button works here or it works better over there? AI has made it very fast to really figure out whether this thing works the way we want it or not. Rise engineering workflows, right? Because you can now do stuff faster, you can actually do two things at a time that can work in parallel. It's as simple as that. And finally, reduce cognitive load on senior engineers. Senior engineers tend to guide, tend to mentor and stuff like that. With AI and what it could do on the software development life cycle, certain parts of this load can be removed from the senior engineer, where AI can actually suggest, build boilerplates and stuff like that, that a senior engineer would have ordinarily done. But there are downsides, right? There's no silver bullet anywhere in any part of life. But there are some significant challenges trying to do this. New forms of technical debt are harder to detect. Certain things we've told AI to do for us, including design, prototyping, and writing code, introduce certain subtle items that out of our own general laziness. Laziness is one of the greatest attributes you can have as a software engineer, simply when you don't do what you mustn't do, right? But sometimes it gets to the extreme where we allow AI systems to create stuff for us, but we don't go through them and presume that everything is going to work out fine. It will not always work out fine. Quality and reliability concerns, similar to the new forms of technical debt, these are things that we see working at the moment, but they will not necessarily scale. But because we have gotten lazier than we need to get, because it works at the moment, we leave it and don't try to see whether there are edge cases we could find around them. So quality and reliability tends to suffer when we leave AI to do more than it should actually do in a software development lifecycle. And brand and US consistency, this is one I've seen personally, where, it might look great, it might look nice, but there are already laid down UX strategy paradigms that a platform already has. If you are not able to feed it into the system, it's going to come up with its own, because AI systems, as far as I'm concerned, are a little opinionated, especially if you don't guide them very well. And finally, team skill evolution and requirements. This is something we'll keep discussing for a while. The fact that AI can now do certain repetitive tasks that we would have used to give experience to young engineers and people in the middle of the ladder, especially at the start of the ladder, at the base of the ladder, they are not able to do this again, and that's usually where people cut their teeth at, right? It's also one challenge I see around using AI in the software development lifecycle. Now, I'm going to talk about the case study where we try to build a new platform, working side by side with an existing platform, but we wanted it faster. It was very simple. We wanted this in 30 days. And it almost felt like the rebuilding of an existing platform, but making it available for another segment of the market. We started from the very start, which is prototyping. The requirements were clear. And in this case, the tool that we used was actually Lovable. There are a lot of tools out there in the market, but today I'm going to be talking about the experience around using Lovable in the software development lifecycle. Now, the goal was very simple: significantly improve speed to prototype. We were very clear about what we wanted to do from the start. We were not saying, okay, let's see what will happen. No, we had one objective. We wanted to be fast. We wanted to be super fast and still get exactly what we wanted. What I made sure I told the team so that we bring to the table was, what is our final product? What is done for us? Especially at the first instance, like you could call it, what is our MVP? What do we look at? And we know we have finished this very first part of things. So our goal was simple: move faster, without compromising the quality, of course. AI-assisted UI generation platforms for rapid wireframing and visual exploration. This is just me trying not to say the word Lovable, right? Lovable was the guy here. And there are a number of them out there, but in this case, it was actually Lovable. Experiment scope. We focused on prototype development for a real product module. Like, this is not hypothetical. I'm not very free to say what product that is, but it's actually a product that's right there in the market today. So this represents an organization that's trying to integrate AI deeply into the design, to development, and soft process, right? Like, we try to look at the software development lifecycle, especially the places I highlighted. Can we prototype faster? Can we use it as our design prototype instead of, say, Figma? And then can we actually move the same code written by Lovable, for example, and integrate it into the platform straight out? Yeah, if you're telling yourself that would be a disaster, you're probably correct. Now, what worked well in design? I'm not able to like very quickly go back to what I said we're going to concentrate on, but if you remember, was items number 1, which is getting that clarity, design, and the actual engineering, the actual writing of the code. This was our experience around the designing. Now, when I tell you it was fast, it was pretty fast. We use Lovable, you know, it's just a human readable language. I can use English, the English language, for example, describe what you want to do, and Lovable is able to put up a wireframe for you. Like, that is super fast. This is something your PM would have done, prototyping with several tools where you drag and drop this and that and that. But it was really, really fast because you just sat back and allowed this thing to just generate exactly the visual that you wanted to show you. So super fast. Like, if I'm to quantify it in terms of man hours, I could say that something that could have taken a whole working week actually took under 1 hour to get done. Multi-dimensional exploration, right? I mean, in that prototype that the PM or even the design team will try to do, they will try this, try that. But imagine using human language to just tell the system to adjust here, adjust there, and you are seeing it do it in a matter of minutes, right? Like, it doesn't take a lot of time. Enhanced stakeholder storytelling. Now, usually, depending on how your team does it, after design, someone has to go through it and approve it. Like, the PM has to go through it, and sometimes you have to run it through some stakeholders. It was pretty fast. Since you're able to produce this very, very quickly, you're able to start getting feedback instantly, almost instantly, because all you needed to do was to share a link to this prototype and people will start interacting with it and they can give their feedback and so on and so forth. This is priceless in a software development life cycle. You would usually do this over several weeks because to even get it ready and make it shareable is a big headache. But now an AI system like Lovable is able to help you do this in a matter of hours, and I'm not kidding you. Now, excellent discovery tool. Like I said, it helps you, like, if you're thinking of doing this or that, you don't know how it's going to turn out for a designer, for example, you can actually have an AI system do exactly that, see whether it works. If it doesn't work, you undo and stuff like that. So very fast prototyping, very fast feedback loop, because you are just looking at this thing and it's doing it right in front of you. But not everything works very fine, right? When it comes to design, we observe certain items, inconsistent styling across components. If you're a platform, sorry, you already have your colors, you have your gradients, you have your buttons and stuff like that. In as much as AI makes you move very fast, we saw you struggle with something like that, right? That consistency across board will look nice visually, but when you want to inspect it to actually build, you start finding some little inconsistencies that break things down the line for you. That was the first gotcha that we faced. Secondly, brand tone was not preserved. I mean, it's similar to like the strategies you have put in the guidelines you have there, you know, font styles, spacing, gradient, and stuff like that. Any designer knows here that UI is very closely tied to UX. Interface is very closely tied to the experience of the user, and these things matter like a lot. Very little movements where you put your CTA call to action, give a space where you let things fly in and out, can change a whole lot of stuff. Accessibility standards not reliably followed. Yeah, in as much as you tell it several times, and you find out that if you have used some of these tools, the more you are telling it to do stuff, the more you will tend to hallucinate, or the more you tend to get confused and stuff like that. I will just put very quickly, because I doubt I put it in here, is that one way we try to mitigate this is to start a totally different project, right? So it brings in whatever was done as a done deal, which it learns, so to say, and you continue moving up on it, instead of insisting on changing the very first project that you created on, say, level. And finally, heavy dependencies on design system maturity. At the end of the day, what we figured out was that you needed a way to let the system know exactly what exists before and very clear ways to make it run very close to that. How you achieve that is something very subjective. Do you want to give it your initial design system? Are you comfortable doing that? What are the plans you have to make sure that it stays with exactly what you're giving it? So that was design. Then, of course, after your design, you are going to start doing your implementations. Here, I'm going to concentrate on the front end. I'm not going to talk about the back end. What worked around the front end? Quick prototyping and scaffolding. Again, you'll be surprised how fast you are able to, I mean, there are parts of the actual code generator that you're able to lift and put into the system. Yeah, if you disagree, the thing is that it works to lift it and put it in there. But if you're a platform, you have to figure that you're doing a greenfield project, and even if it's a greenfield project, certain parts need to align with what was existing before, right? But the fact that you have some boilerplate code that you can actually copy is a great deal. Like, you see your shapes take life from design immediately, even if it doesn't come out very fine, but at least you have those boilerplates, those initial scaffold that you need to get things going. Excellent for exploring component structure. I mean, it gives you a structure. You know, it's not exactly the components you have built before, but it gives you the opportunity to push it here, push it there, and so on and so forth. Any front-end engineer will tell you that that little thing you have told them to push that space over there, or make these two things to stay side by side, in as much as it's very straightforward and easy to the eye, it could be one of the trickiest things you ever have to do. Like, I don't even want to be in that part of software engineering. That's why I'm not a front-end person. Valuable for testing product ideas. I mean, just like the prototyping, you could try to change this, change that on the boilerplate code that you already have, and you see the outcomes immediately, and you're able to do certain things, not because you have that boilerplate. Accelerated learning for junior developers. I mean, where they are lucky to be in the loop here, because usually when AI is in place, people are actually using it because they feel they want to go faster. Junior developers, I'm sorry, usually don't get the opportunity to do this because people feel that this is now advanced. It's more experienced guys that you give it. But for any junior developer who find themselves in a tech team who uses AI in the software development lifecycle, this is actually a gold mine to explore, but some pitfalls still exist there. And what didn't work in the front end? Output not production ready, right? You have those boilerplates, but they don't run to your components. If you have something that is doing buttons for you, for example, and the AI system has not been fed with that, it's going to do its own buttons that turn out looking the same way. But you know that software development is about how much you're able to become modular and reuse stuff. If you're going to have a particular function or class for every single button, I mean, I'm sorry, good luck with that, right? So this is one thing it struggles with, to tend to do stuff differently each time for the very same thing. That's what we observe. Significant code-based mismatch across framework, conventions, established patterns, and stuff. Just like in the design, there are several ways to skin a rat, right? Or something like that. The AI is the best guy to describe that type of thing. It will do the very same thing in different ways. And again, consistency is key when it comes to code bases. So this is one thing we found it to have struggled with. Serious maintainability concerns, including verbose implementations and clear logic and stuff like that. One of the worst things you can do to yourself is to have your AI system generate code for you. You test it, especially functional testing, and that part works, and you feel that everything works, instead of trying to see whether it rhymes in the other steps of the things you are doing. That would be one of the biggest mistakes you find yourself making. So maintainability becomes an issue, and if you are not careful about it, you are just building up the technical debt that you are going to solve down the line. Yeah, exactly. I mean, that's just what it leads to. I'm going to start wrapping up now. Like, what did we learn from here? What did you learn with our experience trying to move faster with AI in the software development life cycle? It's very critical that expectation is managed from day one. AI is not going to do the whole job for you. You have to figure out what parts of the software development life cycle you want to use AI on, right? Is it the rapid prototyping? Is it the design system? Is it your core engineering workflow, whether it's back-end, front-end, or the mobile? It has to be clear what needs to be achieved here. And one thing I've seen that causes a lot of headache is letting the wrong people establish the expectations. Non-technical people establishing the expectations is just setting up the engineering team for unnecessary distraction. So it has to be clear what can be done, what has been done, and incidentally, if you've not done it before, you will just have to be open enough to learn along and change things as you go. So AI experts are thinking not yet at shipping. I've highlighted this, in different times. It helps you build those boilerplates, helps you prototype faster, but I'm yet to see any AI-generated software ready for production, especially on a platform. A platform is a set of features that a particular ecosystem uses. It doesn't just cut it to get a piece of code and hope that it just works on its own. It has to be aware of what was existing, works well with it, and becomes backward compatible, so to say, so that if you're changing stuff, the older things don't start failing and stuff. Mature standard, it's getting the system to figure out what your standards are, right? Are your buttons these particular gradients? How are your components organized, and so on and so forth? The more you are able to give it to the AI system, the more you get closer to what you need. But it needs someone technical, someone who is aware, not just someone who can type the English language and who knows what the actual outcome needs to be. It needs someone who knows the names that components are called, for example, those technical jargon and stuff. I was actually sitting behind someone doing this, and pre-prompt struggled to do the exact thing that was needed until I suggested a keyword that a technical person will use, and it instantly got it correct. So these are some of the things that matter when you're trying to use these things in this system. Constraints unlock AI value. Unbounded AI produces mediocre results. Clear, consistent, specific context, and well-defined objectives dramatically improve output. I mean, that's just a little of what I just said. It's critical that the people who are prompting are the people who know how to build these things. How to build it, not what they should look like when it's built, because this is what goes into the outcome. I mean, in as much as you know what a beautiful website looks like, as much as you know what a beautiful user experience looks like, you have to figure like what is consistent with what is already existing, and so on and so forth. And earlier adoption yields greater returns. Don't postpone it, right? Do it immediately. Hopefully you have the time, start doing it immediately, learn from it, and keep building on it. Come with an open mind. You'll be surprised. You will love one or two things, but at the end of the day, you also see that there are things you need to improve. So how can you start using this like immediately, like tomorrow? There are a few ground rules, right? From what I've learned. Identify one high friction area. Is it prototyping you want to be faster with? You want to get feedback faster? Do you want to get to the first initial designs very fast? Or do you want to get some boiler code for your engineering team to start working with, whether it's the backend, front end, or whatever it is? Make sure you have a very specific target at what you want to do. The smaller the target, the better for you. I'm hoping that the teams or organization have the time to do that. Now, measure both time saved and quality impact, and try to do it honestly. If it doesn't work, it shouldn't be an issue. Anything for me, things that don't work are things that didn't work are things we shouldn't do, right? It just told you what you shouldn't be doing. And from there, I see it like part of the positive knowledge, not that we wasted our time. No, we found out what shouldn't be done, and we can keep moving on. And then measurement is critical, right? Because that's the only way you know whether things are working. How long do you do prototyping before? How long does it take you to get feedback from stakeholders? Was it faster? If it was faster, that's a win. If it wasn't faster, then either you're doing the wrong thing or that is not bad. AI native engineering isn't about automation replacing human expertise. No, it's just about augmenting it, right? I think that's what all of AI is. But the important thing is that it becomes part of the system. It becomes part of your prototyping. It becomes part of your engineering experience, not something you use from this time and the next time you don't use it. So it really takes time, it takes some work, and people need to see that they are getting the value that they actually defined at the start of it. This is actually the end of the presentation. I will hand over to the team to maybe help us wrap up if there are questions coming from the audience or some other things you might want to speak to. Thanks for having me.